All right, we're going to do some conceptual questions. Make sure you have the reading material. You got to have it for this. I'm only going to do a few for this video, probably just do 1 through 7, and then let you guys sort of get rolling. A lot of this is review. If you watch the vocabulary part, it's the same stuff. They just ask it in different ways. I mean, this whole unit, obviously it's about Faraday's law and all that stuff, but that's what it revolves around. They're going to ask you that about 50 different ways, just to make sure you got it. So, with that being said, let us look over number 1. All right, so what did Michael Faraday and Joseph Henry discover? Just what we talked about in the vocab, they discovered that magnetism can produce an electric current in a wire. So for number 1, they discovered that magnetism can produce an electric current in a wire. There you go. And that's sort of like Faraday's law, right? Magnetism can produce an electric current in a wire. Okay, let's go to number 2. How can voltage be induced in a wire with the help of a magnet? So just like we talked about in the vocabulary video, so if you move the magnet in or out of the wire coil, it induces a voltage, creates a voltage. So remember how we had like that wire coil? If you get a magnet and you move it through the coil, it'll create a voltage. So depending on how fast you move it will like, I guess, directly relate to how much voltage is created. And also it'll depend on if you add more loops to the actual coil, just like we saw in that video. That video is a really good explanation, so that'll kind of show you. All right, number 3. A magnet moved into a coil of wire will induce a voltage in the coil. Cool, we already talked about that. What is the effect of moving a magnet into the coil with more loops? Well, just like we said, if it has more loops, it's going to have more voltage, right? So like we said, the 2 ways to kind of create more voltage is move the magnet faster or have more loops of wire, right? So number 3, it will increase the voltage. Pretty simple, pretty straightforward. Number 4, why is it more difficult to move a magnet in a coil of more loops than it is connected to a resistor? So why is it more difficult to move a magnet in a coil of more loops than is connected to a resistor? I'm sorry. So for number 4, if you have more current will run through, and that's going to make a stronger magnetic field, and that magnetic field is actually going to resist the motion of the magnet, right? So again, if you have a resistor on it, more current will run through, create a stronger magnetic field, and that magnetic field will resist the motion of the magnet. So it'll make it a little bit more difficult, right? All right, number 5. Current as well as voltage is induced in a wire by electromagnetic induction. Why is Faraday's law expressed in terms of induced voltage and not induced current? So the answer to this is because current is actually affected by the type of material that makes up the loop. And there you go. So current is affected by the type of material that actually makes up the loop, which is what we talked about. And that's pretty much the answer. I mean, it's pretty straightforward for that one. All right, number 6. How does voltage of a changing magnetic field compare with the frequency of the alternating voltage that is induced? So how does voltage of a changing magnetic field compare to the frequency of an alternating magnetic field that is induced? So for that one, they're just equal. The voltage will be equal. So that's, straight up. There you go. All right, number 7. This is the last one we're going to do for this. What is a generator, and how does it differ from a motor? Okay, so a generator, just like the name suggests, it generates, right? A machine that converts mechanical into electrical by rotating a coil in a stationary magnetic field. A motor, though, motor's a little bit different, does the opposite. It converts electrical or chemical energy to mechanical energy, right? So a generator goes mechanical to electrical, and a motor goes electrical to mechanical, right? So there you go. They're sort of like opposites of each other. So that's it. We're just going to do 1 through 7. Hopefully that kind of jump starts you guys. Make sure you're reading. I mean, this one you just got to read. There's reading material. You got to read through it. It's a lot of different concepts. So, you know, make sure you get these concepts, and that'll be, it's a pretty short unit. It's just, you know, very concept heavy. All right, guys. Awesome deal. Let me know if you got any questions.